This is the solution to the sequences Part B question in 2013 back. And although I gave you an answer today, on reflection I think it could have been improved. So I'm going to put down a fuller explanation, which I'm hoping that you are going to be much happier with. So we'll start with, we know that Vn is equal to un plus 3. We also know that I want to look at the next term in the sequence, so Vn plus 1 is equal to un plus 1 plus 3. So that can be replaced by what un plus 1 is, which is 2/3 un minus 1, and then don't forget to add 3. So Vn plus 1 is equal to 2/3 of un plus 2. Okay? And we know what un is, because un I've got up here. So I can rewrite, let me just get a different colour, un is equal to Vn minus 3. So I get Vn plus 1 is equal to 2/3 Vn minus 3 plus 2, and when I just expand the bracket I get 2/3 Vn minus 3 becomes, that becomes minus 2 plus 2, so Vn plus 1 is equal to 2/3 Vn, and therefore Vn is a metric series or sequence with a ratio of 2/3. Part B. Now it's quite easy to do Vn. We know that the first term, we find the first term of Vn, so V1 is the first term, which is we can type that in by doing, from I did in the class as well. We know that we just find what un is. So we know from earlier un is equal to minus 2, so V1 must equal 3 more than that, which is 1. So the first term, remember it's in terms of n, so we have, it's going to be written as Vn is equal to a times r to the power of n minus 1. So Vn is equal to 1 times r, the common ratio, power of n minus 1. And that's Vn done. Now un is a bit more complicated because un is maybe not a geometric sequence. So we know that un from above is equal to Vn minus 3. And therefore we know how to calculate Vn. So un is equal to 1 times 2/3 n minus 1, but we need to take away 3 from that, and hey presto, it's done. And that was all the marks.